Hello, everybody. This is the beginning of the Space Resources Hangout number 3, live in the Museum of Geology at the Colorado School of Mines during the Space Resources Roundtable Conference that takes place every year here in Golden, Colorado, around this time of year in June. And, and so I have Chris Dreyer, who is vice chair of the AIAA Technical Committee this year. I'm the chair for one more year, after which Chris will take over. Yeah, you forgot about that. And so we thought that it would be useful for those of you who cannot attend the event this year to hear from all the experts who came over this year, about 160 of them, a record number, experts in space resources, in land systems, scientists who study the moon, Mars, asteroids, to talk about the future of our activities off this planet as a civilization, as a species. And so grand ideas are being shared, and we wanted you to hear about it. Chris, what did you think of the week, since you are actually one of the co-organizers in some ways?
Right. So it is just extremely busy for me, and so it's been great to have all these people here. It's sort of the largest conference, the Space Research Roundtable, I believe we've had here from check that, but I believe it's the largest ever. And there's been a lot of lively discussion, lots of great talks about space resources, like concepts for what we might do with resources, to law, economics, to engineering solutions for all sorts of different space resource problems. And yeah, so that's usually what it's all about.
That's true. Yeah. So one thing that wanted to check with you online is whether you have any problem with the audio, because we are in a museum and there's a lot of people here tonight. And so if you have problem with audio, please use the chat to give us a feedback, so that maybe we move to a quieter location inside the museum. We wanted to do this so that you get the feel of the room and the ambiance.
And we'll be pulling in a few people here to talk to you about space resources and their experience at this conference. And
That's right.
One of us will be interviewing that person. So we're also monitoring the chat offline on a separate computer to see if you have any questions, or if you have any issues with the sound, we can change things up. And we ask questions of some of our guests.
Yes.
That's all what you see behind us.
Very good. So we're going to start with a dear friend of ours who is the master organizer of this conference, of the Space Resources Roundtable, and that's Dr. Angel Madrid. So I'm going to invite him over.
So I'm going to move out, and I'll take my seat.
Yeah, very good.
Hi, Laurent.
Hello, Angel. How are you?
Hello, everybody.
Try to settle in.
Yep.
We're on high chairs, a little bit bouncy. It's gonna and we're trying to speak in this microphone that's around here. So,
Perfect.
So Dr. Angel Madrid is director for the Space Resources here at the Colorado School of Mines, and he's the Grand Master of this amazing event that takes place every year, to which our technical committee from AIAA always makes a point of having a good presence and participate in the event to actually bring our own viewpoints, and that's what it's all about, right?
Oh, that's great. That's probably, and actually AIAA has had quite a time this week. They started with their meeting on Tuesday. Yesterday they actually participated in one of our roundtable discussions. these roundtable discussions are very unique because that's the time for everybody to express their views and their opinions. And so Laurent and Chris took over and they spoke on the very important issue of landing pads. If you want to make any mission to anywhere where Mars or Moon possible, and so that was an AIAA-led activity. And so I think it was very successful. I think we got really good feedback from everyone.
Yeah, and actually to set the stage for everybody, we have at this conference this year a very good representation of the people who are making the next landers that are going to go to the moon. This is called the CLIPS program that is funded by NASA, mostly the Science Mission Directorate at NASA. And this, we had several of them in the audience.
No, it was great. This conference has been very unique. We got about 180 people from NASA, but also from ESA and Luxembourg. And it was quite international, probably 8 or 9 different countries. Because we have a lot of representatives from small companies and large companies. We had 4 CLIPS providers. So we had Orbit Beyond, Deep Space Systems, Lockheed Martin, and what was the other one?
Astrobotics?
No. I'm blanking out. But there were 4 of them, and so that gave us the opportunity to have their point of view. Plus all the different people that are doing the work from all NASA centers. So it has been a great opportunity to get the opinion of everybody on this very important topic.
Right, and on the topic of landing, so obviously these CLIPS landers are going to be pioneers, right?
Yeah.
They're going to be the first one to land where NASA is interested in going,
Yeah.
near the South Pole of the moon, and where no one has landed before. So there's a lot of discussion around the challenges that are posed to those landers when they arrive on an unprepared surface, not arriving on a nice fresh pad. So what are the first challenges they have to solve? And if they want to return to these locations or even take off from these locations, and as they grow in power, engine power, and they would face new challenges that may require a landing and a launch infrastructure.
And what was unique about the conversation yesterday is that the commercial payloads were there, SpaceX was there, Blue Origin was there, and so for us it's a good opportunity because we're going to be the ones providing the payloads, the prospecting payloads, the tech demos, and so it's great to have the conversation between the ones that are going to get to the surface and us that want to have some of the hardware there. So I think it was very, very successful.
It's an interesting event. That's right. What about the rest of the week? What do you think? We're at the eve of the final day.
That's right. It's a 3.5 day event. We had the opportunity on the first day to hear the views from NASA, from Luxembourg, and we'll probably get to them in a moment. We looked at the economic, the legal issues, the policy issues of space resources. We talked about the Mars resources, the moon. Tomorrow we're going to close with small bodies. And so it's good. We covered the gamut of all the different places where our resources found. Look at priorities, what needs to be done. We looked at excavation, processing, everything. So I think it's been a roundtable. You can feel the excitement right now that is happening at all levels, and this is a unique time for the space resources community. So let's take advantage of it.
Yes, very good. Amhel, thank you very much for your time.
Roland, been a pleasure.
And again, thank you for this wonderful event.
All the best for the AIAA guys.
Thank you. All right, we're going to have our next guest join us. Hello.
Hello.
Matthias. Bonjour.
Bonjour.
Bonsoir. We have probably some French speaking in the audience, but yeah, we're going to continue it in English for a broader perspective. This is Dr. Matthias Link from Luxembourg. Maybe you want to introduce yourself and what you do?
Yes, I'm from the Luxembourg Space Agency. I'm in charge of the Space Resources.lu initiative. This is an initiative started by the Luxembourg government more than 3 years ago.
Yes.
We aim to promote the peaceful exploration and sustainable utilization of space resources. And we work on many different layers there, on an international level, on finance, on legal and regulatory issues, but also, of course, also on technical stuff and research and education.
Right. Actually, those legal and policy issues came up this week. What did you think?
Yeah, they came up in many presentations because I think in many of these presentations you can indeed ask what does that mean from a legal perspective.
Right.
But what I enjoyed very much about the conference is that it was not actually the main topic. I think people are aware that there needs to be a solution, but in this kind of conference, I think it's good to focus on technical and business issues. Because somehow I think the legal framework will follow the technology and also the business.
Right.
And I think that's what we already see.
That's typically what we see, right? Yeah, the state of Luxembourg has been very active in this domain and probably leading the pack of countries in realizing what needs to be prepared to actually make sure space resources are identified and exploited in the right way, basically. I noticed some people told me after these discussions actually on legal issues and policy, they even suggested that maybe we should have some politicians attend this event. What do you think?
Yes, I think that would be a good idea. Mainly for politicians to realize that this is actually a reality. Because very often when you explain what you're doing, of course, the reaction is that this is total science fiction and extremely long term. And that's not true. I mean, this is really happening, and it is maybe not for tomorrow, but maybe the day after tomorrow, and it is much nearer than what people think. So there is indeed a need also for quality politicians, and then afterwards the legal side to create the right frameworks for this. And as you said, I think in Luxembourg we try to do our best to contribute to this. We have enacted a national law in 2017, but this is for us only the first step. This is somehow clarifying the situation at the national level. But in the long term, of course, you need an international framework to deal with this. And it becomes more and more apparent when you listen to what's going on.
Yes, that's true. Actually, one thing that maybe some of the audience doesn't know, that the first demonstration of use of a space resource, other than the sun, because the sun is a massive space resource, will be happening next year when the experiment MOXIE will land with the Mars 2020 mission that NASA is sending to the planet Mars, in which the MOXIE experiment will extract CO2 from the atmosphere and transform it into oxygen and verify that they could do that. So it's not very far, right?
No, indeed.
Yeah, this first demonstration.
Yeah, and what is very interesting to see is, because what you just said is of course driven by agencies. Yeah. And this is what we will see also in Europe. The European Space Agency is now also increasing their efforts in this domain. And what we have seen is, of course, for the next years, agencies will be the primary drivers here, also sort of anchor customers and early risk takers. But we have also seen over the past days here at this conference that there are more and more companies that are developing business models. And these companies, what I always find very nice is they start interacting with each other. So one company being the supplier and the customer of the other. So we really see a little ecosystem and a new industry being created.
And that's essentially what you predicted, right, in your plan, in your viewprint, in your blueprint for the future of this field. When you look at it.
Yes, we clearly see a new industry coming, and we see the role of our government at least in enabling this industry. And this is something for us, at least in Luxembourg, that is very natural, because since we have started being active in space as a country in the 1980s, we always have encouraged this commercial side of space to be developed. And we focus mainly on satellite communications in the past decades, and we have today very successful companies also that do. And that allowed actually over time to develop really a truly commercial sector in space. And that is actually what SATCOM is today. SATCOM is really the only, I would say, the only part of space which is purely commercial today, which is viable commercially. And our hope is, of course, to see that also with other parts of the space sector in general, and in particular with space resource utilization.
Now, for you, coming all the way from Europe to this conference, what did that mean this week? Did you find the value that you were looking for?
Absolutely. For me, it was extremely interesting to see what's going on in the US, and it is very impressive. I must say, I got the feeling that proactive basically that is connected to space resource utilization.
There's a lot of passionate talks.
Yes.
Very, I mean, from students to professors to new entrepreneurs, everybody was really showing a lot. We have a question online. I can't see it, Paul. I'm going to ask our secretary, Paul, to read it to me.
Why Luxembourg versus interest versus ESA?
I'm not sure I understand the question.
Well, I mean, why is Luxembourg individually interested instead of ESA doing this?
Oh.
I guess that's how I would interpret it.
Well, ESA is interested as well. So Luxembourg is a member of the European Space Agency, and as a member of the European Space Agency, actually, you can have a lot of influence within ESA. So ESA is a truly multilateral, intergovernmental organization where member states have a lot to say, and we have been pushing this since a few years now as well. With ESA. We have signed a specific agreement with ESA in this domain, and over time this has also developed within ESA. And today, ESA, as I said initially, is extremely active as well. ESA just published, I think 2 or 3 weeks ago, a full strategy on in-situ space.
Oh yes, that's right.
Utilization. And I think we will see more. I would have actually hoped to see more Europeans at this conference.
Yeah, this conference. Oh, I see. Yeah.
So I'm very happy that.
Yes. Well, I am a European and an American. So.
Yes. But there are a few.
Yeah.
And on the other side of the Atlantic, we have some events similar to this one. Maybe not with the same history. But we have in Luxembourg, we organize this year for the second time the Mining Space Summit, which is very similar to what you're doing here.
That's true. Yeah.
And we have also from ESA the ISRU workshop. That is actually even more similar because it's very much focused on technology. And both events will be organized in Luxembourg in October this year, back to back. And of course, they are
in the same week.
within the same week. We call it the Space Resource Week.
Ah, very good.
And of course, our hope is to develop a similar community in Europe, and that we will then also see more exchange between the two countries.
Well, that caused some comments about how global this community is becoming, right? I mean, you said you came over to see what the US was doing, US researchers and companies were doing. But this is the point of this type of hangout, is to reach the global audience. Of course, not everybody can watch at the same time zone. Our friends in Europe are probably asleep now, but they'll watch the recording hopefully. And but that's the idea, is that we do need this cross-pollination, and clearly people are in their discussions of thinking beyond boundaries, right? And that has been your experience actually, because Luxembourg has invited a lot of foreign companies to come and participate in your efforts. Right?
Yes, I would say in Luxembourg we are very much used to this, because as a small country, of course, we know that we won't do everything on our own. So our focus is always very much oriented towards other countries, and we have put a lot of efforts into this. We have become quite active at the United Nations to also drive this topic there, and try to, in the longer term, let's say medium term, come up with a framework on how to deal with this. In fact, there's agreements with many countries,
Including the US.
including the US,
Very recently.
and also China and Japan and others, where we try to address this issue. How do we want to regulate this in the longer term?
So these agreements are meant to actually align certain activities between the agencies along grand themes or specific projects? How do you see that?
Yes, typically the agreements that we have signed have two different focuses. One focus is the regulatory part, so legal and regulatory part, because it's a fact that there is some disagreement on a world level. So we need to move forward together and try to find an agreement that suits everyone. So, I mean, they're very clear, easy to imagine things that really need to be addressed internationally. We have two countries, two armies from the same country.
Are interested in
At the same spot, you need a way to do it. So that's a very simple case. Of course, there are others, and so this needs to be addressed. And then the other part in our agreement is indeed technological and scientific cooperation, trying to come up with common projects.
Do you also hope that these agreements will facilitate discussions between countries to find agreements on, for example, issues of intellectual property, obviously rights to technologies and the use of technologies?
Yes, so that's part of the agreement.
Okay. Well, I clearly see that you enjoyed your week.
Yes,
We have one more day, and
great time.
you can enjoy a beautiful Colorado in June.
Yes.
Mathias, enchanté et merci beaucoup.
Merci à toi.
À bientôt. Merci. All right, thank you to Matthias. That was a great discussion with him. And we have another very famous and I'm not gonna call him an old friend because we're both about this.
I was going to say, about 20 years ago, both our hairs were a lot lighter and fuller.
Yeah. That's right. So I don't know if it is I saw you that does that or the kids.
The kids, actually. ISRU has been great. It's been the highlight of my career.
So let me introduce our new guest, Jerry Sanders from NASA Johnson Space Center, and who holds a very important position in resources because he's overseeing the strategic decisions at the agency level about space resources. So Jerry, thank you for joining the Hangout.
Glad to be here.
And we've had several guests already, Angel and Matthias. And basically, the first question for everybody is, what do you think of the ESR this year?
I love it. As I think I said the other night, I've been to every Space Resources Roundtable.
Right, he's a veteran from the
I am a
beginning.
veteran.
That was when? When was the first one?
Oh, I think 99.
99. Right.
So it kind of
It's a milestone.
It's a milestone. And even before that, we had some ISRU teams here before it officially became the Space Resources Roundtable.
Okay.
So I'm obviously a veteran to this organization. This year, I will say, was the best one. Yes. You could tell the level of excitement that occurred as a function of NASA's vision and what they were seeing. During the Constellation program, you could look at the attendance of the Space Resources Roundtable and the type of discussions that they were having, and you could almost track it to decisions that were being made.
Okay.
When Constellation canceled, things dropped off. That's why I came back. The thing that's really great about Space Resources Roundtable versus an AIAA or something else, different conferences, is the people that come here is a wider variety. If you go to an AIAA conference, you have very, high quality engineers and aerospace executives and things like that. But you don't get the university involvement as much. You don't get some of the international involvement, or at least it's not as prevalent in some cases.
And again, it's focused on the major aerospace themes, aerospace technologies.
The other thing that's really great about this one is the diversity of topics. We'll go from legal aspects to business aspects to technical aspects to architecture and big picture discussions. And so you have this dynamic of discussions with a combination of different people that really open up debates and exchanges of information that we just don't see in most other conferences.
Yeah. And actually, for some of the audience, maybe the field itself, space resources, is still part of science fiction, right? I mean, you read it in books, you read it about, you watch a movie like The Martian and so forth. But we see some of that science fiction in those discussions, in some of the presentations.
Yeah.
Right? Very far in the future, massive plans for colonization
The moon
of Mars,
with like this half of it filled with lights from
Right. Yeah, we had a very interesting presentation about a 1,000 people colony on Mars, and the field is interesting because it sort of calibrates itself, right, through those discussions.
Yes.
It does not reject these fantastic plans. It actually tries to see what they mean in terms of the now and the next 10 years and so forth, right?
Yes, and like you said about science fiction, first of all, a lot more has happened in ISRE than most people think of.
Oh yeah.
We have a flight experiment on the Mars 2020 rover that's actually going to acquire Mars atmosphere and make oxygen.
Next year, right?
Next year. We've had ground demonstrations of complete end-to-end ISRU processing systems on how we called it dust to thrust, where we literally dug up material in Hawaii, turned it into oxygen, which was put through a small rocket engine, fired on a simulated landing pad. So you have these things, but like anything, you have to have a vision.
You start with that.
You start with the vision. You start with the big ideas, the big dreams.
Yeah.
And you work on the individual pieces. How do I complete that dream? So it's always good to have somebody pushing the envelope. Oh, I want this business. Oh, I want this colony. Recognizing, that's much farther down the road.
But we may not see that.
Yes.
Or at least you and I may not see that.
But it gives you that long-term vision on what part can I play.
Yes,
as small as it can be.
Mm-hmm. That's right. Well, Jerry, thank you very much for your time. It was a pleasure. And so I'm going to let him go to back to the reception. I'm going to try to get another guest in there. As you can see, very passionate, very enthusiastic participation. And we have another guest coming over. Again, 180 participants. Chris is coming back to keep me company.
So how many people have you talked to?
Oh, we talked to 3, Angel and Matthias Link from Luxembourg.
Okay.
Angel Abud Madrid, the director of the Space Resource Center for Space Resources here. And just now, Jerry Sanders, who is the top figure at NASA for space resources. So his views are very important and usually listened to very well.
We're going to talk to Eric.
Do you want to talk to Eric, and so I can go get some water? Okay, very good. Make sure to talk in the microphone and stay in the frame, and the camera is over there.
Yes.
Right.
But I'll shift.
Yeah, no, you can go get Eric. I'll go get him.
No, he can't do it.
Do you want to?
No, it's fine.
Chris,
Hi.
microphone. Nice here.
We should talk. Make sure we talk to the mic.
All right.
I don't think I know you.
All right. So my name is Guy. I'm a co-founder of Curious. We're an Israel-based company doing multi-regulatory electrolysis.
Okay. I've heard of you this. So maybe I don't know exactly where, but I have.
It's a guy, big words, God the sun.
Right. No, yeah. I mean, the company did this as well. Yes. So, what do you think of the Space Resources Roundtable? Is this your first time?
That's our second time.
Second time, okay.
Yeah, and actually we've had an amazing time. First of all, the breadth of the companies and people that are doing different ISRU advancements, both on the business side and the technological side. I mean, it's amazing. And aside from the lectures and presentations, which were great, so we got to actually meet a lot of the players and even discuss business with some of them.
Great.
I mean, we've made very big advancements in the past year because of people we met last year and we kept in touch with. So not only did we have a great time, I think this is a very, very valuable conference.
It's great. Yeah.
Yeah.
So, what's next for Helix? What are things
so actually things are moving very fast. There's a lot of information that I cannot disclose yet. But we're doing experiments back home in Israel, and we're a prime candidate for the next Israel space lander, Bereshit 2. It's supposed to launch in about 3 years from now. According to our timetable, this is when we want to do our first live demo on the moon.
Great. A molten electronics?
Yeah, molten regulatory process.
What are you going to make with that? Like, tell people what you could make. What's your, so one of the things we do is try to make sure we're putting everything in context, because we have various technological processes to extract a resource, and then that can feed into many different products that can be used in space. So tell us what it is that you're doing.
All right. So basically, molten regulatory process is a process where there's a reactor that you feed with a regolith, basically lunar or Martian birth. And what it does, it heats it up to like over 1600 degrees and passes a very strong electric current in a way that you separate some of the oxide. We specifically work with iron oxide, which means that you put in the moon dirt and separate the iron oxides inside. One side you get pure iron, and out of the top you get oxygen bubbling. And we hope to be the first suppliers of oxygen and iron on the moon.
Yeah. And yeah, it's great. And like with the oxygen, that could be used for breathing air.
Exactly. It could be used for life support. It could be used for propulsion. It could be used for further industrial applications. I mean, oxygen, I think, is the number one sought after element outside of Earth.
Yeah. And then the iron you're producing can be used for structures or tools and things like that.
Structure and industry, and once you have these basic commodities on the moon, it opens the door for a whole load of other companies and other startups. And, we hope that.
Yeah, I mean, that's how it works here on Earth. You have many different businesses that supply services or products at different levels of the value chain, from extracting the raw ingredients like the regolith and building the hardware to do that, to somebody like your company taking that raw material and turning it into a product. But that's still raw, and it needs to be processed and made ready for life support or ready for building things, so manufacturing. So yeah, that is all a network of assisted organizations to produce new future space economy, new fun resources. That's what we do. Great.
Thank you very much.
Thank you.
It's a pleasure.
Okay. How are we doing in the kind of sound department online?
I haven't had any complaints yet, so I guess we're doing okay.
Do we have people listening? Or?
But it's recorded, right?
Okay. So, pretty much.
Karen was online.
Okay. So, hi.
Hi. Yeah, it's a great conference so far. It's been fun. So, how are you enjoying it? You're here, part of the organizing committee. So,
yeah, well, it's hectic. Then I also have talks, so that's to it.
Yeah. So, what were the reactions to the tours of the facilities?
Okay. Overall positive. Yeah, quite. Our facilities are a lab here, in which we making lunar and Martian and space like asteroid type environments, and doing things like concentrated solar to solar power to break our asteroid and extract water from it, to icy regoliths that we're making and then measuring geotechnical properties of them. We have another test bed where our students have developed an excavation rover, and we have a bed of lunar simulant in which you can excavate. We have a business we're partnering with where they do testing in that test bed. And we have a couple other drill projects, student-led and NASA-funded research. So,
Wow, great. Very cool.
oh, and then there's the Habitat 3D printer that we partnered with Icon.
All right, so in other words, you're waiting for many more projects.
Yeah. I've been, yes, all this keeps things very busy.
Yeah, good. It was an excellent event so far. So we have another day tomorrow at asteroids.
Yes, I think at least one of the sessions, 2 sessions in the morning. I know one of them is all about asteroids. We tend to group things together by destination. One day was mostly Mars, the other day was mostly Moon. Other days were kind of, other sessions were kind of economics and kind of bigger picture of the history of exploration, those kinds of things. So, yeah, tomorrow includes asteroids and a lot of talks too. Yeah, close up by late morning.
Okay, excellent. So, what was your favorite thing you learned, I guess, this week?
Well, I think I liked most. But there's lots. I liked hearing from the few lunar eclipse providers we had here. There's 4 of them. Orbit Beyond, Lockheed Martin, Draper, and I'm missing someone.
Drawing a blank, but
Yeah, I'm drawing a blank too. But
too much fun.
yeah. No. Anyway, that's hearing from them, their plans and their lunar landers, their systems, and what they're planning to do. Some have specific plans. Like Orbit Beyond was one of the recent group that won the rounds and funding to actually go to the moon and rather shoot soon with small robotic landers. Some of the others, like Lockheed Martin, are providers are there and will probably bid on later contracts that are big scale type stuff. That's where they fit in better. So that.
So it looks like we have an audience question here. Brian is asking, is China ahead of the U.S. in in situ mining? That's a great question. Well, they're on the surface of the moon. In that sense, they're certainly ahead of us at the moment. But as far as developing mining technology, no, I don't think so. I know they're aggressively working on it, but we have a lot more commercial partners. We have a lot of stuff going on as well. Plus, we have a lot of experience already in this too built up. So
yeah, no, I think I agree. I don't think I can say that they're ahead. I think they are moving pretty aggressively in understanding how to mine in space and mine the surface of the moon, and so we should be.
Well, they have a clear vision and a goal, and that's what they want to do, and that's what they're going to do, and that's what they're working towards. And so that vision is something that they have a long-term vision, and that's something that the U.S. tends to flip-flop quite a bit. And so we make progress, and then we don't, and then we make progress again. So hopefully now we can move forward.
Consistent progress moving forward, and I think we also realize we need to promote and develop businesses to find business cases for those kinds of activities, and that I think will ultimately do very well for us with creating an environment that's friendly to businesses.
Yeah, and an economic-driven system in that sense has very different drivers than a government-driven system, whether that's the U.S. or China or anyone. So I think when the commercial partners get really involved, we'll see some quick changes. So, all right. Let's have another guest here. Mike, you ready?
I'm ready.
All right.
Am I going to talk to Mike? Nice and tight.
We got a microphone here somewhere.
Yeah, it's right here.
Got it.
There. So apparently is working okay. Maybe slide it a little closer so you can watch it here on the screen.
Oh,
Yeah.
okay.
So with me here is Mike Hecht, the first ISRU device ever to go into space and do something.
We came really close in 2001 with MIP. You know about MIP? MIP was the Mars in situ propellant prototype, in situ propellant production prototype.
Okay.
Back then, ISRU was ISPP, strictly for
in space propellant production.
That's right. And it was an embedded acronym. MIP was the prototype that was going to Mars. It was very, very low production compared to MOXIE. And when we lost the Mars Polar Lander, the 2001 mission was canceled.
Yes, that's the sequence.
So that was the first time. I think Dave Kaplan was the PI, but there was a commitment. It was a short list of things we needed to do to get ready for humans to go to Mars. We needed to understand the radiation dose. We needed to be able to understand the dust hazards. We needed to be able to demonstrate what we now call ISRU. We needed to understand the large landing and launch vehicles and how to put large payloads on Mars. That was the short list. I was at the time PI of an instrument called NECA, the Mars Environmental Compatibility Assessment, to study the hazards of dust and soil part of it.
Okay.
We eventually got to fly on the Phoenix mission in 2008.
Okay.
So I can now tell you anything you want to know about hazards of dust and soil on Mars. The opportunity came to take the one final instrument in 2001 that never flew with MIP. But it was a wonderful commitment by NASA to do this properly on a larger scale. And the Mars 2020 mission came along, and I was fortunate enough to get a return ticket to Mars to do this right.
Right, and in the Mars 2020 instrument solicitation, they explicitly requested an instrument to do ISRU.
That's right. Because instrument solicitation, we want to do this kind of science on Mars. Yeah. And in this case, the kind of science had to do with sort of chemical observational but high spatial resolution. Okay, so we're not going to do like Curiosity did, pick up rocks, put them in instruments, stir them around, do mass spectroscopy. This was for using techniques to do analysis. But beyond that, it was open. It was whatever instrument you want. One exception was this preparing for human exploration instrument, where it said explicitly, we want to produce 20 grams per hour of oxygen from Martian atmospheric CO2. Right. And it needs to be a certain purity and a certain production rate. So there were several proposals, and I was fortunate.
Great. And tell us about how it's doing this.
Okay,
in the kind of highest level.
Okay, let me first describe a different instrument, which is a fuel cell. We all know what fuel cell is. So a fuel cell takes a fuel and an oxygen, usually oxygen, produces some stable end product and electricity. So one system you could use is carbon monoxide as the fuel, because carbon monoxide burns. You can burn it with oxygen, you can make a torch. You have seen CO oxygen torches. It burns with oxygen and makes CO2, which, as we know, is a stable gas, and it produces electricity. The fuel cells are typically what they call solid oxide fuel cells. You have them in your power engine as oxygen monitors.
And that's a type of fuel cell. This is one that does this type of process.
And for this type of process, it's the only type that works reliably today. And you have to heat it to about 800 degrees Celsius for it to work. And when it does that, it has this ceramic becomes a selective membrane that allows oxygen ions to pass through it and nothing else. So now all you have to do is split the CO2 into CO and oxygen and drive the oxygen through this membrane with a small voltage and collect it on the other side. So that's how the fuel cell would work. And if you do it in reverse, you put in the CO2, you put in the electricity, you get out CO and oxygen. Okay. So as we do that, it's called solid oxide electrolysis. It's essentially the same instrument as the fuel cell, just running backwards.
Yes.
So the hard part
is you have to, of course, collect a lot of carbon dioxide on a planet where it has a very, very thin atmosphere.
Right. It's mostly carbon dioxide, but there's just a thin atmosphere.
So less than 1% of the Earth's atmosphere.
Right. Yeah. Sure.
So that's what we do. We combine a collection device, a compressor, which is a pump running backwards, and we have this electrolysis system, which is a fuel cell running backwards, and then a bunch of instruments to characterize it. It all fits in a box this big, which kind of absurdly goes in the belly of a rover. And I say absurdly because we don't really care where we are. We're in the belly, we're inhaling CO2 like a mechanical tree. We're exhaling oxygen. And we don't care where we are. We're driving around, and whenever there's a break in the action, we make oxygen.
Yeah, so this is something being done in, like, this is to demonstrate the production of oxygen to make sure this can be done in the environment where we have this very low CO2, we got dust to deal with too. We're not using, in this system, we're not using oxygen for anything yet. That's just, this is to come at some later dates.
Catch and release, basically. So, but the important thing about this, when people hear about this, they say, great, this is how we're going to make oxygen so the astronauts can breathe. This is really not about making oxygen so astronauts can breathe. And we need to do that coming from Earth. They can't wait to get to Mars to breathe.
Yes.
The reason we need the oxygen is because you cannot burn fuel without oxygen. Your car would not run on gasoline without oxygen. That's why rockets have a great big liquid oxygen tank. And if you want to come home from Mars, which is
probably most people
would
do.
Not all.
I know, yeah. Some people find that.
NASA's philosophy is you go and you come home.
Yeah.
You need a tank of liquid oxygen, and it's very, very heavy. So, if you had to carry your own oxygen in your car, it would weigh several times what your gasoline was.
Right.
So, if you can make the oxygen on Mars and fill up the propellant tank, you can bring the fuel, the methane, and the acid, and Mark Watney can come home.
Right. And you can, so there are other concepts for how to make the fuel part of this too, which I believe can work and use some of that carbon monoxide with water, the process to make methane.
Well, the other piece of this exactly is water. You need to make fuel. You need a hydrogen source from most fuel systems. Now, I'm qualifying that because I just told you can use CO for fuel.
Yeah.
And Moxie makes CO and oxygen. So you could just burn the same CO with the oxygen. It's not a great rocket fuel. It's not IISP.
Right.
If you want to do anything else, you need to find hydrogen, and the place we usually find hydrogen is in water. And the only thing we remember is that on Mars, and I think even more so on the Moon, there's plenty of water. But it's a mineral. And like any other mineral, you have to prospect it, you have to find it, you have to excavate it, you have to purify it, you have to prepare it. It's a lot harder than what Moxie does, which is just to inhale.
Yeah, because it's just air in the atmosphere.
So we're a tree.
Yes.
So that would be the next step. It's a very difficult step.
Well, what do you think about the SRR? The Space Research
this has been, I missed last year, I was here 2 years ago. What's wild about this meeting, someone along the way, I don't remember who it was, put up a quick first slide that said that ISRU was really useful for going on the moon, whatever, exploring the solar system. It said, but everyone knows this, let's go on. And that was not true, I think, even a couple of years ago, where people really had to make the case that ISRU was a better option than just packing everything you need to know. So I think there's been a real sea change in recognition that using resources where you find them is enabled.
Yeah, I know there have been people talking and thinking about this for a long time. I know if you look back, you'll see that there was talk about use of resources from just at the end of Apollo, even during the 60s, the first thoughts of what we do. But it didn't become dream of space exploration.
Absolutely. And in some sense, we've always used resources in situ. So in a way, it's a misnomer. ISOU is the wrong term. We use atmosphere for parachutes. That's ISOU.
Okay.
We're using solar panels. That's ISOU.
Yeah.
What's unique about the kind of ISOU we're talking about is that we're transforming things.
Okay.
And we're taking dirt and we're turning it into bricks. We're taking CO2, we're turning it into oxygen. So kind of reversing entropy here and creating a.
We're doing a more significant transformation of materials than we have been doing in the past, like using photons into electrons.
Yes.
Now we're doing a mineral into some useful product.
Now the moon is more challenging than Mars. Just to begin with, there's no atmosphere to just inhale. So it's funny. I heard an analogous argument from Diane Linney saying, "Well, the easiest thing to do is just to take whatever dirt, whatever regolith is where you are, and just get the oxygen out because that's the heavy stuff." And I was sort of amused by that because that's the same argument we've been making for why we do Moxie on Mars.
Okay, right.
The easy, accessible, resource and squeeze oxygen out of it. From there, of course, as we've heard at this meeting, there's mining ice, there's making structures, there's making bricks.
Right. Yes, there's making metals, there's making
galvanic refinement.
there's all sorts of products and uses that people are looking at.
Lots of discussion about the economic system, the legalities.
Yes, yeah.
That's an indicator of the level of maturity that people are thinking of.
Right.
When you make this
Yeah,
work.
and that was something that I've been around in some capacity in space resources for a while, since I've been here at Mines since 2000, starting as a postdoc, and around with the same group of people like Mike too. I started the Space Resources Roundtable, but I didn't attend until, 2003 or something. And my first exposure was with as a grad student with the Mars Society, and particularly the founding convention of Mars Society, which was also the last case for Mars at CU Boulder as a student. And that was my first introduction to the idea of using resources. I then later came here, and that became a bigger and bigger part of what we're doing. What I'm doing now, it's everything. I'd say yes. There's been a growing maturity of the field to recognize it's not just a technological problem. It's a law and policy problem about determining that we can do it perfectly legal.
Now, one thing I
More or
did
less,
not.
it's not the same as digging or starting a quarry, nearby where you live, like pointing out the
Up
mountains.
the hills,
Yeah,
that's right.
not at all the same there, but it's nothing that actually legally prevents us from doing it.
No,
Certainly, perfectly within the rights of a nation to do it. So don't worry about that.
Yeah, and there was a few comments about jurisdiction that are very interesting.
Yes.
One of the things that struck me that I had not seen before was a lot of discussion about debris being thrown up at land.
Yeah, we did hear about that.
We spent a whole evening talking.
Yeah.
A whole afternoon session talking about that.
So that's basically the analysis that suggests that a large lander on the moon would pick up debris that would fly all the way around the moon, to return to your landing site on the opposite side, and hit an altitude of some 20,000 kilometers.
Something like that.
Not 1,000 kilometers, 20 kilometers.
It would eventually come back.
Yeah.
It's not going to go into orbit.
But its highest point is actually an orbital altitude. So these are like your very largest possible landers that we're considering. So we talked a bit about what to do about that. One way is send something smaller at first and build a pad that keeps the regolith from place. That's one of those construction processes you might be looking at. That could be one of the nearest, like soonest activity that's a space resource, like to make something for practical use. Like you're gonna say, Moxie's going to make oxygen, but it's not going to use it.
And that's for Mars.
Yeah, that's for Mars anyway. Yeah, I mean that's for preparing for the future where we'll have exploration on Mars, human exploration. But this is something, and this is also going to be an issue on Mars. We land on the moon surface because it has an atmosphere, although it has an atmosphere. It's dense enough that it's not going to allow material to fly very far. But if you're landing close to a base, your base is going to be sandblasted, unless you prepare the surface. So this is something we're talking about that is one of the things we're probably going to have to consider as like one of the first construction tasks that is space resources.
And somebody raised the issue if a United States lander lands, for example, and debris damages a Chinese lander or somebody else's lander, who's responsible? Who pays? There's a lot of
I believe that terminology is there's a principle of non-interference, that one state with what they do in space cannot interfere with another state. But yeah, if anyone kicks up debris in a big way, it could affect everything on the surface to some degree. It could just be a little bit of dust or solar panels, but it's still an effect. Hey, so I think it was great talking to you.
Same here.
Yeah, fantastic, and really look forward to Moxie.
Not as much as I do.
Yeah.
Thanks very much.
Thank you. You want to? I'm okay. Yeah. Hello, Julian. Okay, how are you?
Doing very well.
So, tell the audience who you are. I know that. So, I'll just Julian Cyrus from a company called Lunar Outpost. So I'm interested in that. Take it away.
Thank you very much. So, first mention, my name is Julian Cyrus. I am co-founder and COO of Lunar Outpost. My brother, Justin, who you can actually see in the background there, and I started Lunar Outpost 2 years ago. We're a space technology company, and our focus is to create technologies that will enable presence in space, specifically on the lunar surface. But we also, our whole business model is to create those technologies for space applications, but also make sure that they have an application on Earth as well. And that's very important for us as a business, so that we create a positive impact here, but we also increase our tech dev and grow our business and make ourselves sustainable in the short term while we have these long-term goals.
Great. So what are some of the products?
That's the question. So one of the great things, first of all, about being in Colorado is that we are close to some great institutions. CU Boulder, Colorado School of Mines, who we partnered with both for facilities and expertise, and a lot of our engineers come out of school here. Technology specifically that has been on table tonight here at Space Resources is our MAP, or Mobile Autonomous Prospecting Platform. And so that's essentially a lunar rover. It's a small, 10 kilograms total. That its job is to map the lunar resources, but it also has that base functionality, and it can accomplish those tasks with the onboard lidar and drill and near infrared spectrometer that it has. But it also has 5 kilograms of payload capacity that we can integrate other people's payloads, and so we can have a prospecting platform that is truly portable to many different missions and many different objectives. And since it's small, 10 kilograms total with the payload, you can have autonomous swarms of these operating on the moon. And so that's how we see that's really a game changer for cost-effective missions going forward.
Sorry.
Yeah, no worries.
Yeah. So great. Yeah. So I know you've been here to the Space Resources before, But what are your impressions about this year?
I think it was a little bit more positive this year in terms of the tenor from the folks. I've been here 1 year before, so I'm not by no means a veteran. But I enjoy really the fact that this really is kind of the nexus of all those different disciplines that we need to have in this conversation. Not only the folks that have been working at NASA for 20, 30 years, but also those terrestrial mining folks, people that are more finance oriented, the policymakers, and those that are legal experts. And so I really enjoy having kind of that holistic approach.
Great. Have you learned anything new this year?
I've definitely learned some new stuff. There's been some interesting research done in extraction technologies. A little bit about those. Having some of those the finance and legal minds kind of mind us as those that are producing the technology, that there are certain things that we need to accomplish. Just keeping that in mind, that's been great. And also, it's been great to get feedback on what we presented as well. Not only our prospects, but also on us as a business. And people have really echoed the fact that we have these technologies. And like, for example, another technology that we have is the environmental life support system that we have down at KSC. The Earth version of that is IoT airplane monitors. We partnered with City kind of Denver here in Colorado for that, and people have seen that here, and they've really positive about that whole plan of creating sustainable business so we can support ISR.
Great, yeah. I think your business is one of a type that we're seeing. I haven't seen, that I don't know of. There's only a few businesses in the country that are building rovers of kind of the small scale that you guys are. But also you're seeing with businesses and doing other types of things or in this area to support eventually work in the area of space resources are also doing work that is near-term development of something that in the near term could become revenue generating and have a product that is useful today, but also clearly contributes to the future, which we're out there using resources of space to do really big things. Your sensors, and I'm sure you're going to get some more work with autonomous rovers and sensing. So I'm just saying, your business is there's this business model of thinking far to the future, but also thinking near-term practical things that you can do today that help incrementally move us towards that future.
I appreciate that. And that's what we're trying to do. And with creating rover, just building the hardware, we're trying to just try to push the conversation forward.
Great. Great. Yeah. Well, thanks a lot.
Thanks a lot.
Yeah. Okay. I think now Laurent's going to come. I was going to step out, but is there a question? You and Laurent want to handle it?
Yeah.
I need to.
Hi, guys.
Oh.
We have a question as well.
Oh, we have a question? Okay, we can answer it maybe. Hi, everybody.
Hello, everyone.
We're back.
Yeah. So a question here is, what's the biggest challenge to in situ, and I assume you mean in situ excavation and resource processing?
Yeah. Okay. You want to take the mining?
Sure. So I think the stage we're in right now is basically prospecting, so developing an understanding of what's there, what form does it have, what are the spatial variations of anything that we might be interested in, whether it might be ice or the regolith itself. And so the next step, the hardest part is once we know that, is actually develop the machines that can then work for many years without maintenance for humans. and we don't really have any equipment or any experience designing these pieces of equipment that can deal with the temperature differences and the really abrasive lunar dust for such long periods of time. So,
yeah, that's right. And on the processing side, I would say probably similar challenges. Of course, processors involve thermal processing usually in many cases. And so now you're finding yourself placing a processing equipment, a reactor in an environment that is really tough from a thermal point of view. The moon is I've seen void atmosphere, so anything that you put there has an illuminated side and a shadow side, and those two are very different in temperature very quickly. And there's no air, there's no atmosphere to equilibrate that temperature along those materials. So now you're facing with a very brand new challenge to actually equilibrate or manage that thermal difference for a processing plant or a processing reactor. And honestly, there hasn't been that much work done yet.
no, there's still a lot of work to be done. All of it can be solved with engineering. I have no doubts about that. But it's just going to take some time before, and of course, funding.
Time, people, and money.
Yeah, and nothing is insurmountable. I don't think there's anything we can't solve at this point. At least I don't think there is. I haven't found anything. But
not for the things that we envision.
Yeah, and I'm sure there are things right now we don't know yet because we just haven't gone to the permanently shaded regions, for instance, and the regulated ice may be very difficult to work with.
We don't even have samples from those regions. All the Apollo samples were in much lower latitudes around the moon, and so a lot of commercial entities are interested in going to the South Pole, and we don't have any samples, and scientists already know that this is a different material, different regolith in its composition in minerals, and possibly in its physical characteristics.
Most certainly in its physical characteristics, particularly in the permanently shaded regions.
Yes,
so, and then we have remote sensing data, but and some inferred data from the impact from Laddie, was it? Alcross and Laddie, yeah. So from that, with models, they found out it's fairly fluffy. That's what they expect, right? That's what responds to the result, but we don't have any direct measurements at this point.
So for those who are not familiar with these acronyms, Alcross and Laddie are orbital experiments that were done in the 2000s around the moon, and Alcross was a small probe that actually went and was targeted for a crash into a crater called Cabeos crater that receives no light from the sun, just because of the way the moon is tilted and the way the sun angle is grazing that region. So you have this crater that never sees the light, even as the moon rotates and around the Earth, and the light never enters the crater. And so there's very good possibility that there would be trapped gases, trapped volatiles, including the sought-after water. So it was the first experiment to try to get a ground truth of what is in one of those permanently shallow craters. And Alcross, when it hit, ejected a plume of regolith and volatiles and gases, and that plume was read by a spectrometer that was on the orbiter, which was called Laddie, that was looking at what Alcross was doing, where it was in. And that spectroscopic reading found that in that crater where Alcross hit, we now know that there is 5.6 weight percent, so 5.6% by weight of regolith is water. And actually it found a lot of other stuff. So.
Yeah, including mercury.
Including mercury, that's right. So
there's quite a bit of mercury too.
So the search is on to actually find more. Are there higher concentration? are they all in permanent shadow crater, or do you find them in areas that receive a little bit of sunlight, not all the time? So there's a lot of questions that both scientists and engineers who are working in space resources are really interested in finding.
Yeah, and it's kind of a chicken and the egg problem, because when you're looking for a resource, you kind of have to know what is mineable, and so you kind of need to know what your machines are capable of doing before you can figure out what you can actually extract from it. But at the same time, we can't design our machines properly if we don't know what the resource looks like. And so right now we don't have either one of those two figured out. And so the most important thing
it's very difficult to make actual estimates.
Yeah, exactly. It's to go there and measure what's actually there, right, on the ground, not just remote sensing. So once we know that, we can make the designs and figure all that stuff out. That's a critical thing.
Well, Paul, I think we have a new guest.
Supporting Hangouts.
Nathan Gelino from SwampWorks, a fellow swamp worker.
Swamp rat.
Is that what we call ourselves? No, swamp rat.
Blue collar.
All right, what's your impression of space resources around here? You've been here before?
No, this is actually.
You come a little bit closer to the mic.
How many people are on?
So this is my friend Nathan Gelino.
Okay. Good to know.
What do you do at SwampWorks, Nathan?
I am the lead for in situ construction. So I work on a lot of things having to do with sintering regolith and large scale construction, additive construction technologies. And I'm really excited about the work that Laurent's doing because he's making some ferrosilicate. And so I get to do additive manufacturing and additive construction with steel.
And we have AJ, another swamp worker. Come over. Say hi to the family.
Hi, family. There's 4 people. 4 people watching.
They're asleep.
4 people are watching.
They're asleep.
Any questions?
Yeah. And so this is AJ Nick, who is also another SwampWork rat.
Co-founder.
Yeah, that's right. You want to talk a little bit closer to them? Nathan, don't go anywhere. I want you guys to tell the people who could not attend what you thought. What you thought of the week.
I think it was a good conference. Talked about a lot of different technologies. I think there were some really good discussions.
Yeah. How about those good controversies?
Yes,
you love those.
There was, and there was actually a lot of good tense comments.
About what? What do you remember?
Well, I mean, a lot of it's about NASA's roles, what they should be, what they shouldn't be, right? And actually, I really was excited to see how much commercial involvement there was and how many commercial people were standing up saying things and saying what they wanted to do and stuff like that. So I thought that was.
Did you think that there was a lot of candid and honest remarks?
I think so. Yeah. I think it was healthy. I think there was a lot of things said that hopefully will make people think and I really hope that the commercial sector can learn from some of the things that were said and we can move on and just do cool stuff.
Right. What was the? Yeah, Nathan, go ahead.
Yeah, I was just going to say that I've been to a lot of conferences, I've seen a lot of that kind of stuff, but I think that this has been much better than a lot of those because it's kind of like a condensed version where everybody gets to really talk to each other much more. It's in a really awesome location, which helps that, facilitates that. But I also really like the roundtable format because
so the roundtable, let's describe for the audience who cannot be here. The roundtable is really the auditorium is free to express opinions during about an hour.
Yeah.
So the topic is set more or less, and then people just go at it, right?
But what's really cool about it is that you get to hear a lot of people with a lot of knowledge passionately debating the things that they believe and how to move this forward. And a lot of people everybody has a different opinion on how to do that. Whether they're private enterprise, government, university, and everybody has a much different opinion.
but everybody's really passionate about it, so it gets a little bit heated, but it adds a really interesting perspective that, you know, the people like AJ and I, and for some a little bit you, Laurent, who are kind of head down in the trenches really working on stuff. Sometimes it's hard to understand the bigger pieces that are moving around, but when you can hear that from those people, you know, it really gives you a new perspective on the issues that you're working in, the environment that you're actually working in.
And don't you think that people are more accessible in that environment?
Yeah, absolutely.
And I had two favorite quotes that I actually wrote down in my notes from today's round. One was by Dan Britt,
Professor at UCF, University of Central Florida.
And he was talking about NASA, and he said that leadership is risky. And I thought that that was a really right-on quote, because if you are going to be a leader, you have to lead somewhere. And if you're leading somewhere, you're leaving the known area, and that's risky.
And are you willing to take it?
And are you willing to take the risk? And that's critical. And I work for NASA, AJ, we all work for NASA or NASA contractors, but we want to see a little bit more risk. We want to see our leaders, you know, move us into a direction where we can, you know, advance all of this stuff. And if you have a failure along the way, who cares? It's fine. That means you're pushing the envelope, you're learning, and you'll do better the next time. So that was one of my favorite quotes for tonight. The other one was by Rob Mueller, who I don't usually like to take quotes from Rob because I work with Rob too much. But he said something that was really interesting to me and maybe a little bit controversial. So I'm sorry if it angers anybody. But he said it. The text behind this one was NASA funding all of this development of ISRU technology. And Rob stood up and said, "Stop trying to milk the cow. There is no cow." And, you know, I thought that was really interesting and correct, because NASA is not the DoD. We don't have huge sums of money.
Budget, that's for sure.
You know, we only have limited resources to go and apply at this stuff. You know, we're nothing compared to the commercial potential of what we're all trying to do here. And so let's make that work. You know, that's the cow that we're all after, actually. So let's make that work. So I thought that was a really cool quote. It's catchy. And I think our next round of Swamp Works shirts should say, "Stop trying to milk the cow. There is no cow." Because it's kind of zen.
Especially with the gator.
Yeah. Right. So
I can say I went to this conference 3 years ago, and there is got to be like, I don't know, more than double amount of the commercial parties that are here.
Yes, that's right.
It's intense. It's a lot longer. So I just think that's really exciting, and
and you start seeing these companies talk to each other.
Yeah.
Right. What do you do? Oh, I need that.
Right.
It
just strengthens them and makes it
better. I think that's part of that answer. Actually, don't look all the time to the government, and see if you can find a partner that helps you.
Another thing that I've realized since I was here is the ISRU community. It's kind of a cool and unique community in that we all have, you know, something that we're trying to develop, and we all have a little, you know, we want it to be our thing, right? But in reality, everybody seems to be more concerned about just pushing everything forward instead of just trying to encapsulate their own little piece and not sharing information. And so that is one of the things that I think makes this event really powerful, where you can learn a lot, is that everybody kind of lays their cards on the table, and so you can stack the deck in the way that you want to further the things that you're interested in. So we talk. I'm interested in ISRU construction. You go find the people, and you can talk to them, and they're willing to talk too, because everybody here just wants to collaborate and move forward together.
You were obviously particularly interested in that session on landing infrastructure.
Yeah.
You're gonna come talk to us?
Ready?
Yeah, in a minute. And so, what did you think of that roundtable? This was a roundtable. Come back in there.
Landing infrastructure.
Yeah, the whole discussion about the challenges of landers, and then do they need a solution that would include landing pads? What do you think of that?
Well, I think clearly the answer is yes, if we want to have any kind of regular visits to the moon.
I mean, the stuff that Phil Metzger put up showed about how he said basically that everything, all of the ejecta actually goes into orbit and goes around the planet, and, around the moon in one time, and then impacts actually pretty close to where you ejected it from, which was interesting. Yeah. But the critical part about that is that if you have assets in space orbiting the moon, you can't do that. Otherwise, they
go through plumes of debris.
Yeah, so it's not just, usually when we're talking about landing pad things, we're concerned with damaging the landing vehicle, or if this is later on when we have lots of assets on the ground, it's about damaging those other assets on the ground.
Right.
But that kind of always sounds a little bit far away, but it's not far away because we have right now stuff orbiting the moon.
Yep.
And so if you're landing on the moon, you have to coordinate your landing and the plume that you eject into orbit to make sure that it's not going to blast all of the stuff in space.
And one of the things I thought was interesting that was Blue Origin actually mentioned that it was actually more complicated than I was originally thinking, because I've always thought of it as a NASA aspect, where we're saying we're probably going to land, we're going to make a base, we're going to do certain things. But NASA has talked about wanting specific science things. So Blue Origin did mention we may go different places because we may be tasked or paid to land somewhere else. So how do you always have a landing pad everywhere you land? So that's another interesting aspect.
That's a very good point. Yeah.
And you know, I hadn't thought of that before, but with this things going on, I'm starting to wonder whether there could be a small deployable thing that could land as a precursor to a new landing site, and maybe prepare something.
Actually, which is
so
something that
really cool.
The person, Juliana Fishman from SpaceX, hinted at. So,
right. If you could go,
we're not looking to solve this problem, but if some CLIPS landers want to.
And I thought that was really interesting because it's not just we're going to make a base and make one landing pad in your base. It could be a lot more complicated than that. So, I think I've always understood the story as you can still land on the moon. Like, it's not on Mars. There's cratering issues. The lander could get like swallowed up, right? But on the moon, there's less of that, and it's more about ejecta and spray and issues with orbiters. And so I think there's going to be a big time, when you're hearing all these people talk and they're tasked to go land and do those things, there's going to be a large period where we're not going to have landing pads. And, that's becoming very clear. And so at least we'll be hopefully getting data and learning more as it goes along. But hopefully we'll figure out a small deployable thing that can go make landing pads anywhere. Because I think that's really what you get.
My main question about that topic was about, the launch aspect, because these things are really large, and it's one thing to say, okay, I'm going to mitigate my thrust on landing, thrust high, and then I'm going to kill my velocity, my delta V early, and then move down slowly. When you go back up, you have to push right there, right? And so if you have unprepared soil under it, clearly the modeling shows that there's a shock wave that gets created and just excavated.
Ask the Morpheus team.
And that was different for the lunar module. Oh yeah, you're off camera. So.
You can't be off camera.
So that was different for the Apollo lunar module because the upper stage is the one that left, and so the base was actually.
It was the flame trench or
it was arranged that way. So that would be very different.
Well, yeah, I mean, on Earth we use water to solve acoustics and all things. You have those luxuries, but we talk about mining it, and so we can recreate what we have here. It's just a lot of work.
I haven't heard that one before. Use the water on the moon to actually do it.
You can maybe recover it. Do you know where you put it?
You know what? I have a little bit of a different thinking about water on the moon. Clearly, that's one of the things that we're going to, there's many steps, right? Many steps. But if you're like me, you're kind of you have a longer view because you're thinking about infrastructure. And so in the longer view, one of the very first things that we're going to want, not for sure, but it's relatively likely, is water. And if we develop the capability to mine water at a large scale like we want to, and a lot of the commercial people that we've talked to today want to do way more mining and way more water production than what NASA is talking about, then I think we need to stop talking about water as a scarce resource and start thinking about water as a readily available resource.
Oh, that's a good point. Yeah, that's right. Yeah. Well, here's someone who is also interested in construction, just like Nathan. Thank you, AJ. Thank you, Nathan. Hey, come over.
Am I the last guest?
Well, maybe not. I don't know. Possibly. So, all right. Well, we have Jeffrey Montes from AI Space Factory. And what is that? What is that about?
Space Factory is an architecture and technology company, and we're a multi-planetary architecture firm.
How about that? A multi-planetary architecture firm.
So that means that we have terrestrial interests and space interests, and we're trying to create a self-bootstrapping company where we have an Earth stream and a space stream. And what that looks like right now is 3D printed buildings.
Yeah.
So we just won the 3D printed habitat challenge.
It was organized by NASA.
It's been going on for a few years now, and the grand finale took place about 5 weeks ago.
Mm-hmm.
And we took first place.
Yeah. What did you build?
We built a 1 to 3 scale habitat. Ended up being
for how many people?
4 people. As this is one of the NASA requirements in the competition is 4 people for 1 year. It was it's a hotel. So one crew comes in for a year, they exchange with the other crew, and it was 15 feet tall. So it was the tallest 3D print made continuously ever.
Wow.
And we placed 3 windows in the wall with robots. So we were just watching. We won because we interfered very little with the construction.
With the robot. Yeah, that's right. Yeah. And the material had also requirements, right?
Yeah, the material had to be a Martian relevant material. This kind of came, the requirements came from the old Mars fever. And then we all love Mars. I still love Mars. But anyway, basalt fiber was a high scoring additive. So we used that. Mm-hmm. It's also very strong. Mm-hmm. And we used PLA biopolymer. Mm-hmm. So we made a composite material that outperformed concrete.
So now we have a printed, terrestrial version of a Mars habitat.
I'm going to show. Can I show a video?
Maybe.
It might work.
Go through.
See if this works. Oh yeah, there you go.
Yeah. So this is the video of the printing of what do you call this thing actually?
Marcia.
That's the first Martian habitat terrestrial. Built on Earth.
Yeah.
But with techniques that could go to Mars. So, what does the AI Space Factory do other than winning a challenge?
So we're about 40 people, and we have most of those people are doing architecture on Earth in the old-fashioned way.
Yeah. Are you an architect?
I'm an architect by training. Yeah. I've been doing space architecture since my middle of my graduate studies at Columbia, and from there I just moonlighted until I got one win and then another win, and I kind of just built on that.
Nice.
The company right now is, in terms of space, is growing. And we're looking at 3 areas. One is construction technology, so kind of like what I just showed. But that doesn't just include polymer bases, but things that we haven't done yet, personally, but that are relevant and central. We're looking at not just habitats, but unpressurized structures like landing pads.
Yeah.
And number 2, we're looking at integrated master plans, which brings together the construction technology, robotic, human labor, all happening in an integrated way. Right. And finally, habitats and environments, interior environments for all destinations.
So was this a good conference to come to this week?
Yeah, I was just talking to Anya and Paul about it, and it was good for 2 big reasons, I think. Three reasons. One is I now understand the state of the art in lunar ISRU, in Martian ISRU, and tomorrow near Earth bodies.
Yeah. They'll come into the picture.
Yeah.
sooner than than we all think.
Yeah, some people think it's easier to mine water on an asteroid than on the moon.
Yeah, and I think they may call our attention when they say, "Oh, we need to take care of this one."
Yeah.
Or we need to do some to learn more about it.
Yeah, so tomorrow's going to be all about that.
Mhm.
Very exciting. Number 2 is you meet the people who are behind the state of the art, and this is an industry that we need allies. We all need to work together.
Good. Yeah, that's been a recurring theme from people. Yeah.
Yeah, and I like that a lot. I like when people let their guard down around each other and they collaborate.
Yeah.
Then everyone else lets their guard down. And actually, that happens in cities too. When you go to New York, everyone's mean to you. You start getting mean. And when you come to Colorado and everyone's nice to you and polite, you start being polite to everyone.
Oh wow! Big plug for Colorado.
and it works. It works instantly. You can be a New Yorker your whole life. Come here, and all of a sudden people say,
Wow.
"Good morning. How are you?" And you're like, "I'm great now." So it's great to be in Colorado.
I'm sure the
Brooklyn,
Tourism Bureau of Colorado is going to pick that one up.
Brooklyn is a little harsh.
Yeah.
Well, no, Brooklyn's good. Manhattan's a little. And number 3 is you learn about the history of the industry, and you also
Which is important.
Yeah, and you get your finger on the pulse of people who've been doing this for a long time and have had their hopes up and have had disappointments, and the young people learn from the older people, and the older people, the veterans, they get rejuvenated by the enthusiasm of the younger crowd, and
fresh ideas, and that's the place where you hear some new things.
Yeah, you hear new things, and you also get just a good sense of the sort of culture.
What do you think of the roundtable format?
It's good. Yeah. I once went to an MIT symposium where they had a microphone that was a square-shaped pillow,
and they threw it across the room.
And I think we should adopt that next year,
I've seen that.
because you can it's fun, it's fast, and you don't have to have a talking stick. But there's a talking cube, talking to the cube.
And believe it or not, I've seen a NASA workshop do that. So
let's do it. It worked. It worked well. It got good audio quality. So, and it's good. It's good to have a moderator who can direct the conversation as well, and prevent monologues.
Now, one thing that I picked up during the couple of days is, there were certain themes that you were particularly willing to bring up sometimes that were not really addressed, right? So, what are those in general terms that you think are not really paid attention at all by the field?
Well, I was one of a few people to bring up social dimension,
right?
And having a knowledge of our cultural history, and when we go to new places, who tends to benefit from that exploration and who tends to suffer from that exploration.
Right.
We don't have native populations on the moon or Mars, but this is not about native populations. It's actually about labor and ownership. And so, and labor is a dynamic that will continue to be there, even if a lot of it is robotic. And also, of course, ownership and agency is going to be major. Another thing I brought up is the fact that when we're talking about resources, these are all of a sudden a lot of people have an entryway to the industry that can be directly utilized terrestrially. So I made the simple example of missile technology and rocket technology being a kind of dual-use technology. They are. One goes to space, another one is a war weapon, and there are very little non-military and space uses for those things. But something like mining, autonomous construction, prospecting, these things are, and of course imaging, whether it's remote or ground truth, these things have pretty direct applications on the planet Earth. That means that we can solve some of the funding issues possible.
I see.
And allow people to participate in things that they perceive as helping as opposed to hurting. So that was another point I made, and I think the biggest issue, the biggest message was, let's try to create a bootstrap within our own operations to have terrestrial applications, help planet Earth, and basically taking the mandate of technology development from space and saying, look at all this new stuff.
Yeah, these are issues that are in the background and very little addressed by engineers. Right? They tend to want to stay away from them, and that's a reflection about the engineering field in general. I think that if you're technical, you should stay technical and not worry too much about what's happening inside. But the fact of the matter is that we are people, and we're people of countries, we're people of the world, and we live in a society. We cannot just be technologists. So other people in our past have made that choice, and we've had consequences. So I think one aspect of space venture, bringing more activity into space, calls upon the need to really bring more people along in this, to take part of this, rather than just a few going out there and basically, dictate what they're going to do with it. So there is first of all the diversity of the workforce, representation of the workforce in those decisions, and also on maybe right now in a more academic way, but there is a need for discussion about when a recent author published a paper of how much of the solar system should be left in the wilderness, right? Instead of going after every single body of the solar system to do whatever we want with it. Well, I think that's worth a very good discussion, or at least a good debate. We're actually thinking of having that kind of thing on the Google Hangout, the AIAA Space Resources. Yeah. So if you can think of other type of themes like that are neglected, this is a place to maybe start a conversation.
Yeah, I totally agree with that. I think a lot of frontiers throughout history have been described as infinite.
Yeah.
But here we are.
Yeah, here we are.
2%, 3% annual growth, and infinity goes away really fast.
That's right. Hey, Jeffrey, thank you very much for your time. It's great for you to stop by.
Yeah, you're a great host.
Enjoy the rest of the evening.
All right.
All right, guys, come back, and I think we're going to probably close our hangout. We have one question that I did not address here. What do you think of using Gateway? Okay, so Gateway is the proposed station, essentially, or outpost around the moon in a lunar orbit that will help NASA both do remote sensing of the moon on a continuous basis, but also host astronauts that can possibly do more observation or more complex observation of the lunar surface, and also practice being outside the radiation shield that is the Van Allen belt for us. So that will be a possibly long duration stays for astronauts in an environment that is hostile from
closer to deep space
radiation point of view. So they're exposed to more radiation, just like in a more deep space environment. I think. I mean, I'm not an expert on Gateway, definitely. We do talk about it here at the conference, about the role of Gateway to serve as a waypoint for landers that could maybe deliver more cargo, maybe on the surface of the moon. So for us, that means more equipment, more more ways to prospect, to understand the moon and the resources than the regular, and also bring things back to be studied at Gateway possibly before they come back to Earth. So these are positive point of view. These are attributes.
And a future station for refueling, refueling station.
That's right.
For the future. So.
Yeah. So the challenge of Gateway though is possibly it's comes from its orbit where it a very long orbit every 7 days, and the trip to the moon and back from the moon is definitely longer than a direct low lunar orbit. So those are significant drawbacks in terms of frequency of access, possibly. So we'll see how that evolves. Definitely, it can provide for a lot of information if it gets good. So,
we'll have to see how it develops.
Yeah, exactly. With that, we noticed that we've had quite a few attendees, so that's very nice. Thank you very much, everybody, to have been with us with this AIAA Space Resources Hangout at Colorado School of Mines, live from the Space Resources Roundtable. So we're going to sign off for the night, and I hope you invite your friends or anybody interested to watch this recording.
Or next time.
Or next time, and then we'll invite you for next time as well. So
have a good night.
Have a good night from Colorado, and enjoy your day. Bye-bye.